plus 3 divided into x squared plus 7x plus 12. Procedure here is very similar to dividing in ordinary numerical expressions. For example, if we had 317 divided into 6,892, we would divide 317 into 689 to start with. And so similarly, we proceed by dividing, instead of all of x plus 3, we begin by dividing x into x squared. The first term here into the first term there, ignoring all the other parts. Let's refer to that procedure as D for divide. X divided into x squared, we write x as the answer. If we divided 317 into 689, we would write 2 as the answer. In a numerical problem, the next step would be to take the 2 and multiply it by 317, which in this case is 634. We repeat the same procedure in algebra. In other words, we would take x and multiply it by all of the divisor to get x squared plus 3x. So far we have x as the answer there and 2 as the answer there. These are quotients, but we refer to these, because the problem isn't finished, as partial quotients. What would be the next step after having completed the multiplication here? Well, in ordinary arithmetic, the procedure is to subtract. So 634 is subtracted from 689, and the result is 5 and 5 there. Similarly, we subtract and get 4x. Let's call those two steps that we just have done, where there was multiplication after division, followed by subtraction, DMS. So far, the procedure involved dividing, multiplying, followed by subtraction. What is the next step in ordinary arithmetic? Well, the next step is to bring down the next number, in this case 2. Similarly, we bring down the next term in the algebraic problem. Let us use B to illustrate that step. So, divide, followed by multiply, followed by subtract, and followed by bringing down a number. Those are all the steps required in setting up a given quotient. The cycle simply repeats itself now over and over again. After you have come to this point B, which means bring down a number, you begin all over again and begin by dividing. It's a cyclical procedure. Once again, we repeat the steps, and it is x divided into 4x is 4. And we put plus 4. It is the answer there. Just as we would have done here when we take 317 into 552, the answer would be 1. That's the divide part of the solution. Followed by multiplying. That means 4 times x plus 3, which in this case would be 4x plus 12. The remainder is 0, and so the solution is completed. In this particular example, we have 317 by 1, but when we subtract, we have a remainder. And the remainder in this case is 5, 3, and 2. In my numerical example, you're used to seeing numerical remainders, so here is a solution and a procedure that you are likely familiar with. In this case, I have set up the dividend so that there is a zero remainder, and consequently, the quotient, the full quotient, is x plus 4. Here's another example. Divide 15x squared minus 4x minus 5 by 5x minus 3. Let's put down the initials of the operations to the side here so that we don't forget the order in which. First thing we want to do is divide the first term of the divisor into the first term of the dividend and get a partial quotient. In this case, it's 3x. Now multiply each of the terms of the divisor by 3x, and that amounts to 15x squared minus 9x. Then subtract. This part is 0. This part is 5x minus 5. Bring down the 5. Go back to D. Divide 5x into 5x. The answer is the next partial quotient, which is plus 1. 1 times 5x is 5x, and finally minus 3. The next step is to subtract, and in this case we get negative 2 as the remainder. Now you want to write the final answer this way. Be careful that you do it this way in all of the questions of this textbook. The answer is 3x plus 1 together with the fraction minus 2 over 5x minus 3. Here's another example. Want to divide 5x minus 2x squared minus 4 plus 3x cubed by 1 plus x squared. Now, there are several important points that have to be shown to you in this problem. Number 1, we are dealing with polynomials. I've explained to you in an earlier tape that polynomials must be written in either ascending or descending order of powers. The dividend here is not in the proper order. We should, if we write it in descending order of powers, and in these division problems, you should begin with the highest power. You should have 3x cubed as the first term, followed by the x squared term, followed by the x term, and then finally by the constant. That is the expression written in descending order of powers, and that must be the way the problem is set up. One other important point. If you have the dividend in descending order, you must have the divisor in the same order. So, rearranging the terms before starting to divide, the dividend should consist of the following terms in this order: 3x cubed minus 2x squared plus 5x. If the divisor is written in the same order, then obviously x squared has to come before the 1. But notice there's a gap in the polynomial. The gap is that the x term is missing. It's missing because its coefficient is 0. In providing the solution to such a problem, division of polynomials, always include that missing term to avoid misinterpretation and to avoid errors. So you should fill in the missing term as I have done by putting 0x here. So 1 plus x squared in descending order for the divisor is x squared plus 0x plus 1. And for the dividend in descending order also, it's 3x cubed minus 2x squared plus 5x minus 4. Following the order of which the operations are applied to division questions, we begin by dividing. So we have x squared divided into 3. The answer is 3x. Followed by multiplication, we have 3x cubed, followed by 0x squared, 3x times 0x, and then finally 1 times 3x is 3x. The next step in the procedure is to subtract. That's 0. This is equal to minus 2x squared. This is equal to 2x, and we bring down the minus 4. We divide x squared into minus 2x squared, and the answer is minus 2. Now multiply. We get minus 2x squared plus 0x, and finally minus 2. Subtracting, that's 0. This is 2x, and this is minus 2. That is the remainder. We have run out of terms in the dividend, and so that is how we know we must stop, and the result here, which is the difference, is the remainder. The final answer is expressed in the following way: 3x minus 2 plus 2x minus 2 over x squared plus 1. Our next problem deals with polynomials of two variables. For example, we want to divide a squared minus 6b squared plus ab by a plus 3b. Polynomials in two variables have to be written in descending or ascending order, as explained before. Therefore, the dividend is not written properly to begin the solution here. If we begin with a squared, then the term with a in it must follow. Finally, the term with b squared must be last. The order of the letters in the divisor must also be in the same order. So we have to write a plus 3b first. That is, a first followed by 3b. Now, if we change the order of a and b around, which is permissible, then this is what it would look like. But we would have to start with 3b followed by a. If we take this second order in our problem, we can see that 3b into minus 6b squared is minus 2b. If we multiply, we get minus 6b squared followed by minus 2ab. If we subtract, we get 0 there, and we get plus 3ab for that one, plus a squared, bringing down the last term. If we divide 3b into 3ab, the answer is plus a. 3ab is the result when multiplied there, and plus a squared is the result when multiplied there, and the remainder, as you can see, is 0. So minus 2b plus a is the answer. If we use the earlier format in the problem, we would have ended up with the same answer, but a minus 2b would be the order of the solution there. In the next example, we have x to the fourth minus y to the fourth divided by x minus y. Here again is an example where we're dividing by expressions which are polynomials in two variables. Now, there are several things that you have to be careful of here. Notice that if we begin the dividend with x to the fourth, the next term in the dividend would ordinarily be x cubed, followed by x squared, followed by x, and followed by a term without x. That's descending order. Now, there is no x cubed term there. So, what we really must notice is that if this polynomial in two variables were properly written in descending order, then there are several terms with zero coefficients. Observe. This is the same as x to the fourth plus 0x to the third, followed by y, plus 0x squared, followed by y squared, plus 0x, followed by y cubed, and as the last term in the dividend. Now, going through the sequence of steps necessary to solve such a problem, we take x and divide it into x to the fourth. The result is x cubed. If we multiply x cubed by that now, we multiply and get x to the fourth, and then we have minus x cubed y as the second term. Subtract this part is 0, end up with x cubed y. Bring down the next term, 0x squared y squared. Divide x into x cubed y. Be careful now, it's plus x squared y. Multiplying, we have x cubed y minus x squared y squared. Subtract, we have x squared y squared. Bring down the next term, which is 0xy cubed. Divide again, plus xy squared is the result. X squared y squared, xy cubed. Subtract again, it's xy cubed. Bring down the last term, and we have y to the fourth. Dividing x into xy cubed, we have plus y cubed. Multiplying, we get plus xy cubed, and finally minus y to the fourth. When we subtract, we have 0 as the remainder. So that's the final result, and I want you to be especially careful that there were placeholders included in the problem initially, because those variables did turn up as the division process continued.